Hey guys, let's write some code today. I don't know if you have heard the rambling. A lot of people talking about how Python, especially large loops in Python, are super slow. There's a lot of videos on YouTube if you haven't seen them. And you know what? I decided to let's do some coding. Let's write some code today, exploring how does that work, if there's ways around it, and what kind of solutions Python can offer you if you're dealing with a lot of data, right? So let's do it. Let's write some code and see. We're gonna do it hands-on. And by the way, this is not well polished, guys, so you're gonna probably see me stumble a little bit to get this thing going. But hopefully this is interesting to you. Okay, let's go. First, we have to have a reference. Usually people compare like with something, right? C, Java, C++, whatever. We're gonna use C today. So I'm gonna get some base C code here, very basic C code. Let's call it main. Let's see. Here goes. Let's include. I'm just gonna have the reference here for us. Oh, that's the DIO H, right? And we're gonna let's write a main function here for our basic C loop, right? And what we do here, we're gonna just declare an unsigned integer for our let's accumulate the counter in a huge loop. How big? Let's do something that's reasonable for my machine here. So let's define a loop counter. Loop counter max. And let's do something like in the order of 100 million. I just put one just for terminating the loop, right? So in that, what we do is we're gonna just do a plain, simple, old school starting at 1, and as long as I is less than the loop max, we'll keep doing it, right? We'll keep doing it. There we go. Let's accumulate it. Accumulate the index. And that's it. We need to time it. Let's time it. For that, let's include the time.h library from C. And if I'm not mistaken, this gets us the cloak T. I'm just going to get the start time here. Start time for this loop. Getting the processor time. Clock T. In the beginning. That's it. When we finish, we get end time. Call clock again. There you go. This should do it more or less. And let's print out this. Let's get some nice space here around. So I want to have a nice space between. So the lapse time for this loop here will be. I think it's a float. It's a double float actually. This thing. Will be. Oh, I might need to calculate this thing before, but it's going to be a long float. A long float probably. Let's put just 6 decimal points. And the accumulator will be a decimal, long decimal. right? And this is going to be a pure C loop. And let's do some nice spacing here. Yeah, so now let me calculate this thing, because I have to take in consideration, they don't give you, of course, C doesn't give you the time in seconds. You have to actually get a macro to do so. So elapsed time, let's do a double. Elapsed time will be the end time minus the start time. Start time, right? And this has to be cast to a double, because that's what we're using. And here comes the magic. Is this macro here, clock per second. That should give us the proper time now in seconds. This should do it. And of course I have to print from here elapsed time and the accumulator, whatever I got from that thing over there. So let's see. This is as far as we're gonna go. Well, not quite. There's gonna be more C coming down the road, but that's the beginning. This is just plain, nothing special, regular C loop, right? Just let's compile it. Let's use GCC. Okay, let's do this on GCC, right? Let's compile main.c. Give me run loop executable and be bold, and let's run the loop right away. Let's see what we get. Oh, no, something's not working. Oh, nice. I have problems first with semicolons all over the place. Let's see if what else I forgot here. Yeah, that was missing. I think it's just a semicolon. We'll see. Oh, there's one more. ACC unsign. Oh, unsign long. This is going to be a big number, so start time. Start time. I'm misspelling here. Let's start time. Right? After a little bit of pain, we got our C loop to go. And here we go. We have 236 milliseconds, more or less. That's what we're getting, right? 100 million computations just accumulating. This is what I get, with C. Let's compare that with Python, right? That's the point right now. And let's see what we get. I just got installed Python 11 came, I don't know how far in the future you might be watching this, but Python 3.11 just came out, and let's use it, right? Let's put it to use. And what we're going to do here, let's compare with Python. Let's get main.python, and let's just start just with the very simple Python code. Just going to protect against just use the standard Python so our code doesn't run if it's imported in a package. And let's do a loop, right? So for I in let's use a range, right? And for us, I have to define the same thing here. How do they call that? Loop counter max, right? Loop counter max. And let's use type hint here. Right? Of course, Python is not static type. This is just a hint. Hopefully, this is going to change in the future, at least as an option. Right, we'll see what's coming. So let's get our gigantic number again. And that, that should be 100 million. Yes, 100 million. And just for the sake of termination, loop termination comparison. Okay, now here we go. We go all the way to the. And what we're gonna do? We're gonna accumulate. We're gonna just get this accumulator, also an integer. We don't have to worry with Python in terms of size. We don't worry about that in Python. Just Python is whatever. It's an object. You know, it's gonna store whatever you need. Right. Right. And let's do the accumulation. Right. And that's it. That's it. Let's do a print. And let's print. Let's get some spaces as well. Elapsed time. Elapsed time. Oh, I have to time it. Yes, for timing, let's import the time standard library, and there's a very nice. Oh, we're gonna use a start time here. Start time is time. Performance counter, I think. This gives you everything already in seconds, everything ready. So the only thing we need to do here, let's use the F strings, right? Come on, let's use F strings here. And the elapsed time is gonna be simply the, if I call time, perf time, counter, and I subtract start time, I get the time right away. And just for the sake of making sure we have the proper computation going on, let's print the accumulator later as well. And that's going to be just printing out ACC, getting a few lines here so we get to. That's it. That's all I need for to test it in Python. Let's do it. Let's run it. Okay, let's see what happens. Let's do just Python. I have already my virtual environment on, so 3.11. So if I just check in the version I'm using here, I'm using 3.11. So Python main.py, and no compilation errors. Why is that? Okay, coding in Python, right? But here's the problem. Whoa, here's the problem. That's a big deal. That's a lot of weight, right? 14 seconds, and here's the problem, right? So compared to 230 milliseconds in C, the same loop in Python more or less gives me about 14 seconds, which is 2 orders of magnitude above what Python delivers out of the box and on a similar loop, right? This is the problem, right? Let's try to solve this. First, let me organize the Python code. Let's do this. We're going to do a lot of comparisons. We're going to call a lot of stuff from Python. And the other thing, let me get as well. Let me get this reference here. I'm going to put C in this other JCC aim.c. I'll put run loop. And let's just do the run loop here. I'm just going to keep the reference here for, yeah, that's going to be our reference for C. Let's organize this code here. Let's make it nice, right? I'm gonna do some Python here. Let's code a nice framework for so we're gonna do quite a few tests here. And for that, let's just start. Let's do a result. We're going to call a function. Each function will run a certain approach to this loop, and we're going to measure the time and how it works. And we can compare all the approaches, and we can try different things and see what happens. But for that, let me build the infrastructure first. Let me import from data classes, right? For data classes, import data class, right? And I'm going to have a class called result, right? And this class will be a data class. Data class. There's a lot of things for me. And I'm going to have the accumulator, right? And the accumulator is going to be an integer. And I'm going to have the elapsed time. time, which is going to be a float, right? And I'm going to have maybe the function name that's going to tell us what approach we're doing, which is going to be a string, right? And the nice thing is to move the sprint. Let's create wrapper method here where we actually have the sprint going on, right? So what we're gonna do is return a string, right? It's gonna be elapsed time, so the elapsed time will be, so I'm not gonna do this calculation here. It's gonna be a self dot elapsed time. Accumulator is gonna be a self accumulator. And probably we're going to need to have here as well the function name, which is going to be self function name. Okay. Should be good. This is just going to be what I'm planning to do is just get, call a function that's going to return this class, and we're going to have to time every single function, right? We're going to have to do this every single time we call the function, and we're going to make sure we know exactly how long that function took to run. And for that, for no repetition doing that many times, let's do a decorator, right? Let's get a decorator. For decorators, are always good to bring from func tools, import wraps, and let's code our decorator would be like a timer, right? And this timer is going to get a func, and for that func we're going to have to define a wrapper, right? And this wrapper is going to be we're going to have to decorate it with wraps. And if I'm not mistaken, you have to pass the function here, if I'm not mistaken. Right? And the wrapper actually gets all the arguments that would be passed to the function. Right? Positional arguments and keyword arguments. Let's get them. Here they are. And here, every time I call the function, let me calculate now the time it's going to take to run. And for that, we just need to do a start time here, which is going to be a float, right? And we're going to do the time perf counter, right? Now I call the function, but this function is going to return a result. That's going to be a result, right? And let me just call func, passing the arguments that I got it. So this is just a decorator, right? And whatever keyword arguments, I'm not going to use keyword arguments probably, but that's it. And when it's over, I can calculate now I can use this object that I received it back and calculate the elapsed time, which will be, again, time perf counter minus the start time, right? And that gives me, yes. And because this is going to be used with different functions, we're going to get the func name from wherever func we have been given. And for that, we just call the property name function. That should do it. Once we are done with that, the function has to return this response, and this decorator has to return the wrapper. Right? Just the function. I'll call the function just the wrapper. Whoa. Okay. So that was a lot. Let's see if we can just get, well, it's complaining because this is now shadowing. We don't want this anymore, so this goes away. We don't need this anymore. Goes away. Right. Actually, Before I do that, I'm gonna need this. I'm gonna need to create the function now. I'm gonna create, like, let's call it pure Python loop, right? A pure Python loop, and this function will do what? Exactly what we did here. And it's gonna return, after it does that, return response, a result, sorry, result. And here's a little problem. I have, the only thing I'm calculating inside here is the accumulator, so I have to return the accumulator, which is ACC, but I don't have the timer. The time in the function name is not going to be calculated here, so I'm going to partially initialize this data class, which means I have to have default values here. Let's do that before we get in trouble. So let's say float. Let's start with 0, and let's start the func name with an empty string. That's just for, let's not worry much about that. Okay, so this is it. This is just our first function running on pure Python loop. You know what? Pure Python loop. And what we do here now, we don't need this anymore as well. What we do is we just call it result, which is the int result type, will be equal to call pure Python loop, right? And then what I do is I print as an f string, maybe. Oh, f string. Forget the string part of f. And just call the object result and call the wrapper mode. Okay. Let's see if this thing is working appropriately. Let's see if we have any compilation errors or something like that. So far, so good, but we don't know with Python, right? It compiles as it runs, so it's going through the loop. And apparently no. Oh, that's a problem. I got a 0 elapsed time. That'll be amazing. So why did I do that? Why do I have 0 elapsed time? Start times a float. Oh no. When I call the wrapper, I'm calculating the time here at the elapsed time. And it's time perf counter minus the start time. This is the running of the function. Okay. The representation itself, elapsed time. Elapsed time. Accumulator. Function name. Not obvious to me right now. Why I'm getting the result accumulator here. I'm initiating with 0. The func name is not printing either, so which means none of this is being called. Okay, none of this is working. Oh, wow. Hopefully you guys are screaming over there. I forgot to add the decorator. Just minor detail, right? So it was not decorating at all. Okay, so let's do it one more time. So the idea why this thing thinks, let's prepare. Let's try other things as well. Let's try. Here we go. So we got like 7 seconds now. And the accumulator is pretty much the same number, so we're doing the same amount of computation. It's varying a little bit, right? So, but still, I mean, 7 to 14. I don't know. There's some cache that happened right now. If you look into, yeah, I got some. No, it did not cache. I don't know. There's some going on, but it's still, I mean, in terms of timing, we're still operating in kind of 2 orders of magnitude above C, right? Seem to be doing a little bit better. Let's try other approach. Now it's easy because you have all this infrastructure here. Let's do, what else can we do to kind of simplify this using Python still? We can try to do, for instance, is we can try to use list comprehensions. Do you think that's gonna make it better? If we do a list comprehension, does this make better or worse? For that, let's get accumulator here and let's get a list and x for x in another range. 1, 2. What am I doing? Let's see, range 1, 2 loop counter max. And let's use the built-in sum function to get this out. Here's the little problem, right? So this is a huge, I mean, 100, not huge, but well, it's big enough to take a lot of memory. This is going to take a lot of memory to calculate. And then what we do is we just return the result, right? And just for the sake of, let's simplify. I'm going to just comment this for now, so we're not going to run both, otherwise we're going to have to wait a lot. And instead of running the pure Python, I'm going to run the list comprehension function. Let's see what we get. Let's see what we got right now. Okay, no major improvements. As you can see, we're still in the seconds. And actually, it seems to be getting worse. Whoa, got worse. So first things first, is probably because they were allocating all the memory. And then we're calculating the sum. So it didn't work much better for us. Let's try something else. One thing you could do to get rid of the memory is get like a generator, right? Generator instead of a list, right? Let's get a generator. So we just, it's pretty much the same code. But we're not gonna use a list. We're gonna use a generator. So we don't, this doesn't use as much memory, right? See if we get any palpable benefit in our loop. Same thing here. Let's do the results. Pretty much the same thing. Result, and then we're gonna do the generator loop and see what happens. Let's run it. Let's see. Well, clearly not making a big difference. Okay, we're back to kind of the same time as doing with a pure Python loop. So clearly we're not finding a solution here, right? This is not the way to go. So Python loops are, if you use the pure language, they are long. They are really they take a long time because of all the because of not being static, right, and checking all the types and everything. Python does a lot of stuff that has nothing to do with the loop itself, right? So what people really do then? Let's just start exploring serious solutions for this right now. The first serious solution for this, it's probably for most people the only thing you need. When you hear about Python, especially in data science, you always hear about Numpy and Python and the libraries that come along with it. The whole, data science library, right? And what do you need to do to use the library? Look at how difficult it is. So, pip. I have a virtual environment here. Pip install Numpy. Right? I just about to get Numpy. Yeah, I have Numpy now installed on my virtual environment. For that to do, you see, it annoys me when I have this. I don't have the latest version of pip. Let's just correct that. Upgrade. By the way, this is nothing to do. It's just me being me. Yeah, just got okay. So we have now what we have installed in our virtual environment, basic and Numpy, right? Just set up totals in pip in NumPy. How to use it? As simple as that. Let's come here and import NumPy. Import NumPy. That's NP, that's the standard. That's what most people do. Nope, we're not going to use the data science framework. Okay, now we're going to create a function here for NumPy. We're going to time it. Timer, right? We're going to call it NumPy loop. And for that, what we do? We're certainly going to have an accumulator. And there's a very simple function, NumPy, called aRange, which creates a vector of the size you specify here, which is going to be from 1 to, it's very similar to range, to the big loop counter max here. And I can call, in important, I have to call actually the sum function from NumPy, right? And what I do, return this. I'm curious. Let's see how much, what we get now, running exactly the same loop, doing the same thing with NumPy. NumPy loop. And let's try it. Let's go for it. Let's see what we get. Python main. Whoa! Here we go. So we have approximately now, with minimum difference in code, right, in Python, we have sort of C performance. Actually, we have C performance, by the way, right? Let me run again. It's yeah, about 240 milliseconds, and I'm doing if I run, and I'm running Python from the, I'm loading the interpreter and everything, and I'm getting 299, a little bit above what C can do. For most people, I think you would stop here. So this is why people do. That's why NumPy is so important for data science. That's what's really being used. But we're not going to stop here. We're going to go a little crazy now. There's another option. Because, why I'm saying that? Because you might really need performance. You might be really serious. And we seem to get a little bit more than what you get from C. So you might want to explore something even deeper. And one thing, one place you could go is actually, the next step would be to have a thing called Cython, right? Which is, it's not Python. It's a mix between C and Python, right? It's not written in .py files, right? And we're going to do it. We're going to actually create a Cython module here. And we're going to create in a very simple way. We're going to create a very simple way. We're going to do this like this. It's going to be we're going to do the simplest way possible, right? And he goes, well, I guess it's the simplest way possible. You never know, but what I'm doing is I'm going to create a file called cyloop.pyx, and Cython is written actually in pyx files, right? And what you do here is very similar to Python. You define a function, a Python function. If I define a Python function here, this function will be visible from Python because I'm going to import this module later into my Python file, into my Python module, right? So here you go. So we're going to call it, let's call it run, right? Got to run. And I have to get, I'm going to get the loop over there. The counter. How did you call it? How did we call it? Loop counter max. Loop counter max. And I'm going to get this. This is going to be an integer coming from Python. right? And then I'm gonna do old school loop, right? But here comes the difference, right? You define the variables using the CDEF, which is the C definition, and that instead of Cython, instead of using a Python variable, which is a Python object with all the overload, we'll use a C type, which is pretty much just that, right? There's no object, no nothing around it, right? And this is what I'm going to do for an accumulator. Well, and it's going to be, and then you use the C types and sign long for the accumulator, which is start with 0. You still don't have to worry about the semicolon here, which is a great bonus for me. I hope so. Let's see. We're gonna then let's do the loop, which is gonna be the iteration loop. It starts on 1, and oh, see, the semicolon is not coming back. And then let's just do a while loop. While I smaller than that loop counter max, right? What we do is we accumulate. We get accumulator plus 1, plus y, sorry. And then let's not forget to increment our counter, otherwise we're going to stay here forever, right? As simple as that. That's what we get. And what we return our accumulator. And by the way, just let's use the type hints here. There are also type hints when it comes to Python here. So that's it. That's all we need to do. Very simple, very similar to Python. The only difference really is in the definition of these variables here, right? That you use in CDEF. But other than that, this is regular Python code. Here comes what's really different. Instead of calling the Python interpreter here, I have to compile this. And to compile, I have to install Cython. And to do that, I do Python install Cython. I should be good right now. And that's why you should use maybe setup tool. If this was a more serious exercise, we would have the setup tools and install this in our virtual environment. But we're not going to do this right now. We're going to do just to use the command line Cython. We're using Python 3, and we're going to compile this file called cyloop.pywex, and this should give us a C. So with this Cython utility, I just compiled my pyx file into a C file. Right now, that's a C file. If you have a look on it, yeah, I don't know if you want to have a look on it, but if you want to have a look on it, if you have a look, you're gonna get scared. This is all generated by Cython. Don't do it. And let's just use now GCC to compile it. Okay, so here's a little bit of a problem here. You have to do, when you think the minimum parameters, you have to use this FPIC, because it's going to be linked later on as a dynamic library, right? Which is, or DLL. If DLL, I guess if you're on Windows, for Linux, like I'm doing here, it's going to be an SO file, and I have to include here my libraries, both in my virtual environment and my Python installation. And I'm going to cheat in this one here, and I'm going to get a copy here. So those are actually where my libraries are. And what we're going to do is we have to compile this cyloop .c into, out of it, we want to have a cyloop.o. So this is just compiling the source code in C. Let's see if it works. Apparently did. And the last step is we have to compile into a library, into a dynamic library. For that, we use GCC shared. This is the key thing. And we're going to compile cyloop .o, and out of it we need sciloop so file, which is a library. Well, if everything was good, the only thing we need to do now is come to our Python file, right? And like we did with Numpy, we just import it. We just import sciloop. That's it. Let's see what happens. Let's create another function here. I'm gonna call. See, I'm not worrying about timer there inside the Cython because I'm gonna do everything inside Python, right? The infrastructure we created here earlier. So let's do Cython loop, and for that, I just need to call. Right? I just need to call my library, the Cython module now, and whatever function I define there, I have to pass the parameter though. I have to get yes, right? And that's all I need to do. And let's see what comes out of this. Right? Let's see what comes out of this. Result in so Cython loop. Let's see what we get. Let's see what's going on. We're going to run both. Oh, wait a minute. Cython got a lot. Oh, that's comparable to the pure loop. Something's wrong, right? We did something wrong because this is we're back in the bus. We went back to the bus, back on the bus again. Okay, so let's look what we did. We did something wrong. Oh, and if you look into this, I defined two C variables, right? But look what I'm doing. The while is comparing a Python variable with all the loaded objects. That is not supposed to happen. Hopefully you guys caught that. And let's see, loop counter max. Let's create a C variable. And this, I'm just creating a C variable. I'm copying the same value from here, and I'm creating a C variable to be compared in the loop, because it's going to happen like millions of times, 100 million times, right? So, and what I'm doing now is I'm getting that value here. That's all it is, right? Now, everything inside the loop that does the calculation is all C, nothing Python there. Bad thing is we have to go again and do all the fun thing again. We have to call the Cython function, Cython utility. We have to compile the output file, and then we have to compile the library again. And we just did it. Well, with that in mind, I think we should just run Python again and see what we get. Main.py. Oh, okay. Here we go. So we got a little improvement, right, over NumPy, but yeah, we got an improvement. It's being consistent. So every time I run, it's running faster than NumPy. Look at that, right? Of course, my machine is doing other things in the background, right? So the absolute value is kind of complicated because there's even the recording going on in the video here. So the absolute value is kind of not a good reference, but the comparison is probably better because they're running right after each other. You see that you do get more performance from Cython than you have from NumPy, right? But it's not gigantic, right? But you squeeze more out of it, by the way, just to go against me. But typically it's getting a little bit better, right? But let's say that's not enough for you. This is a really critical, important part of your code, and you have to get it super optimized as possible. And you don't want to lose your Python. You don't want to lose most of your code because this is just one part of it, right? You don't want to lose your base, right? So then, what do you do? Well, the next thing you can do really is to create your own C Python extension, right? And here we have to think about that. Python, since the beginning, since the inception, right, had this idea of allowing C extensions to be part of it. So in a lot of it, Python interpreters actually, well, at least the reference one, the C Python is written in C, and it's very well. It's supported C extensions since the beginning. What I'm going to do right now is I'm going to do the simplest way possible to create a C extension to our loop here to test our performance. Right, that's what we're going to do. Right, and for that we have to create a folder here. Let me create a, which I'm gonna call loop module. Loop module. Okay. In this loop module, we're gonna create a file that's gonna be actually our C module. Now, C extension module. All right. For that, let me call it loop module. Let's see. There's some conventions of how do you call these things, right? And here comes. Well, to get a really good idea of this, you have to, if you Google Python C extension, extensions, documentation. This is where you go. There's a bunch of documentation about this. What we're gonna do now, we're gonna do with 3.11. So this might change depending on the Python version you're using. Let's see. Let's see what we do here. There's a lot of now standard code that we have to define to create our C code here. On this first one is include the Python header. The header, right? There's this initialization here of clean. I don't know exactly. Just initial condition for everything, I guess. This is all cookie cutter stuff from the documentation. And we have to create, first thing, we're going to create the function itself, which is similar. We're going to create the function that's going to be the loop, right? And for that, everything here is going to be a Py object, object, right? It's a pointer, of course. And we're going to call this function loop run. Loop run, right? And it's going to receive, of course, all of them have the Py object self. Self. But then after that, we're also going to get some arguments. So we're going to get, specifically, we have to get the counter, the max counter, right? So we're going to get this argument. And that's how things start here. So again, we're back in writing C code here again, right? So for the specific function, we'll create again. We'll do the loop. So we're going to create. Now let's not be silly, and we're going to have to get the value from Python. Loop counter. Max, and we'll see in a moment how we get it. We're gonna use unsigned long, right, for the accumulator. Okay, for the accumulator, and what's 0? Here comes the first trick. In order to get the parent parameters from Python. There's this. You have to use these functions that are part of the C Python C library, C API. Okay, and it goes more or less like this. To get the arguments, you got to do something like pyarg horse tuple, right? And you pass to it the arguments you got, right, from here, right? Yeah, the arguments you got, the pointer to it, right? Here, okay, there's a string that will define what kind of type is and where you're going to store it. So in our case, we're going to store in this counter loop max here, which we just created in the stack. And this is, I thought when I initially read it, it had to do something with the printf, convention. No, you have to look into it. For a long integer, you have to use k, right? Just go to the documentation. Whatever it is, it's specific for each type, each variable type. So if this thing goes bad, that's what you're. If things go bad, things didn't work. So return no, and get out of this, right? And we are writing C, so semicolon come back to play. Let me see if I'm not forgetting mine. Okay, so now comes the loop itself, the old school loop. For, right? Let's define our unsigned long I, which starts on 1, and if I is less than the counter loop max, we keep doing it, and now here comes, we increment our loop counter, and we accumulate, right? Accumulate I. As simple as that. Don't forget a semicolon. This is it. So this is the core of the loop. Okay, this we have been doing it all over and over in comparing everything, right? So, and then when we're done, we're going to return it, but we're going to return the accumulator. So this is actually pi long. This is actually a function from the library to wait a minute, from long. So I'm passing Python the accumulator. So this is what you have to use. Every interaction between the C module and your Python interpreter, the C Python interpreter, has to be controlled by those functions, right? That's why it's not necessarily the simplest thing to do, but it's not the end of the world either, right? So here it is. Here's the code we're going to be dealing. Now comes again a few things that you have to add for the sake of using the API. One thing you have to have is to define all your methods, and it's an array where you finish with no values. And here's the thing. Here's where you define how you're going to call things in Python. Very important, right? It's going to be run, the module we're going to do. The function is going to be called loop run. Forgot exactly what that the type of variables we're going to be using. Yeah, so we do get variables, right? Arguments when the method is passed. And the next thing you have to do is define your module, which is something like this as well. Right, let me show you guys. Let me get this thing here as well. This is just the module definition, generic, right? Another thing, what's important here, name of the module, we're going to call it loop. So this is what, very important, I think we're going to have to use this when we import it from Python. We don't care about documentation right now, and we don't care about any sort of interpreter status or anything like that. And here comes, very important as well, this loop methods is actually the array, which lists all the methods are going to be make available to the Python environment. And of course, we only have one here. The only thing we're going to be worried about is the one method we have right now. And the very last thing is this initialization function, if I'm not mistaken, mod init function, right? Mod init function, right? And we call another function from the interface. We're gonna pass forward. We don't care much about this. We don't have much to do here other than return the module itself, right? Which is a Py module. Create. With the creation of the module, the name of the module, is on the loop module thing. The definition. I think loop module. Yeah, loop module is the definition of the module itself. Okay, loop module here. And let's see. We cannot forget our semicolons. This is an array. Has to finish with the semicolon. Okay, this is a struct. Had to finish a semicolon. Oh, there's some problem here. Yeah, I'm misspelling here. I'm happy got it. Yes, this is create. Loop module is the way my name is. This is mine. This should do it. This should be enough to get us. Now we cannot avoid creating a Python package because we're going to have to compile that. We have to create a setup. So for that, I'll setup.py. Inside the same folder, we have to create a setup.py. Okay, what goes in there? Let's use distools. From distools, core, we import setup, and we import the extension itself. So now we're back into the Python domain. We're just going to set up a package. So the name will be module. Doesn't matter this thing much. Module 1. It's going to be an extension. This extension, we're going to call it loop. So maybe we define over there. And the source is, this is for compilation. So the great thing here is that the setup will take care of all the C compilation we did manually before. It's going to be done all inside setup tools, right? And we only have one source file, which is loop module.c. That's the only one we have. And that's the only thing we have, no more. And then the setup, right, will be done with the name of the module. I think this week, whatever we want, loop module. After that, we have the version. We really don't care. This is version 0.1, whatever. And description should be a what? This is okay. Oh, this is a C extension. C loop extension. That's it. And last one, I think the extension modules we are adding to this. This is, I think, important. It has to be the same name we defined up ahead. Has to be the same one over there. This module we define here. Okay, so if we made no mistakes, see what happened. If we made no mistakes, right, we should be able to install this package with setup tools into our environment, right? Let's see if that's the case. To build it, you just do Python setup.py, build it. It's going to compile it. What's going on here? Oh, I'm in the wrong. I have to get into the. I have to get into the folder. Okay. Let's do again. Let's do a Python setup build. Okay, so we got some compiler errors. It wouldn't be fun, right? Let's get some. Let's see what happens here. First. Bad. That bad name here. So let me see. Const. Right, const. It's probably the appropriate thing. Let's see if we can. Sometimes one error and see one error, and then you get a bunch of them. So let's fix one by one and see if we. No, there's one more. There's one more, which is pylon from long. Oh, it's when I'm... Oh, here we go. There's some spelling here. This is a long capital. It's the function pylon. Okay. Let's see what we get now. Whoa, we get compilation. Okay, if things were fine, well, we got a compilation. We're going to install now. Next step would be to install Python setup .py install. In theory, we have our C extension installed into our Python virtual environment, so we have it there. So the only thing we would need to do is come here to our Python module again, import it, right? Just import in our Python module this function, the C extension that we just created. And we called, if I'm not mistaken, we call it Lou. Yes, showing up already. That's good news. Showing up in IDE, which is good news, right? And then let's create the function. Okay, timer. For that def, let's do C extension loop. C extension loop, right? We're not going to do anything here other than we're going to have the accumulator. It's going to be an integer, of course. And for that, we have to call our loop, and I think we call run. And already IDE is recognizing it, so it's good news. So at least it's finding the method. And with that in mind, that's the only thing I have to do now is return it. And here we go. Let's call the function here result C extension loop. Now let's see what we get. Let's clean up and go back to our Python main.py. Here you go. Whoa! Look at that. We got an order of magnitude faster when we coded our own C extension, right? Actually, we're getting it way faster than our C implementation. Look at this. So when we did when we wrote our own C extension for Python, we're getting one order of magnitude of better performance above standard C, okay? Why the heck is that? Why? Well, my guess is that what happened is that we didn't do any compiler optimization for our C code. When we wrote our C code, we just didn't, there's no pragma, we're not using any of the fancy features of the compiler. And of course, when Python is optimized, is a C program, right? And it has all those optimizations turned on, and when we actually install our C extension into Python, it benefits from all that, although the code is pretty much the same. So we get one order of magnitude. So this is when you get serious. So my point, guys, I think that's why Python is so popular. If you need it, here's we just went through 5 resources to make your Python code much faster in the bottlenecks you need it. But still, you don't need to write C code all the time. And I don't know about you, but I would rather write Python code than C code. But if I have to write a little bit of C code to make Python super fast, I'll do it. And yet maintain my all the libraries and all the ease of use of Python. Hope you guys enjoyed this one, and hope to see you guys soon. See you. Bye bye.